So in this lesson, we are going to take a look at another diagram that's really, really important for our heat calculations that we're going to look at over the next two lessons. And so now we're going to track. So we looked at phase diagrams and we saw at certain temperatures and pressure we'll be in a certain state. Now we're going to look at how much energy is required to go from our different states, and we're going to look at it in a graph. So a couple facts before we get started. Heat facts, if you like to see that, because everything's about to get hot and spicy up in here. But heat is the change in energy during phase changes is known as heat, and it's measured in joules. Okay, not like the jewel you put on like a ring or anything, like the diamond or sapphires, but joules is Joules, joules, and that's our measurement of heat, also known as J. The energy required to heat 1 gram of water 1 degree Celsius is a calorie. Okay. And 1 calorie equals 4.18 joules. That's kind of that. Well, 4.18 you're going to see again. So just kind of think about that when we get to it and kind of come back to it. But that's a calorie. And that's kind of how we process our food stuff too, as we think about calories, is about how much energy our body's going to need to expend to heat up the water in our bodies, and that's where we're getting our food from. Energy is released or absorbed during our phase changes, and we can graph it. Okay, that's what we're going to look at right now. Lines on our graph that are slanted or inclined, they're going to represent the phase or state of matter. So it's going to be a solid, liquid, or gas. Okay, when lines are straight across or at a plateau, that's going to be when a phase change is happening, like melting or vaporization. Now, if you're starting from left to right, because that's how we read in the United States, if our curve is going up, which means we start at a low temperature and rise to a high temperature, then we're heating. If our curve is going down, which means we start at a high temperature and we go backwards, that means we're cooling. It's the same concept. It's just understanding the difference when someone's saying, I'm using a cooling curve, it means they're starting in the gas phase and going down to the solid phase. Or if I'm in a heating curve, they're starting in the solid phase and they're going to the gas phase. Okay, so here is our heating curve. Okay, and you can see it has 5 regions. So I have the solid section, which is right down here, it's slanted. Next, we're in a phase change, which is when we're going from ice to water. Okay, and you're going to notice here that we're going to talk about it, but it's happening, there means there's 2 phases happening simultaneously. Okay, then we have another incline, we're there in water, so all this heat energy for water. Then we're going to get up here, we're going to plateau again, where we have again another phase change, this time water and steam. And then finally our steam section, where we can still increase our temperature, but we're going to stay a steam. Okay. This is really important to go back to our reactions. Kinetic energy and temperature increases on any diagonal line. Okay. And the potential energy on any horizontal line, the temperature remains constant. So here, let's do this one. So this long one right here where water stays as liquid, okay, my kinetic energy is increasing, but my temperature is increasing. But when I get here to point L, I'm going to start moving from a liquid to a gas. My energy is going to increase, right? However, my temperature stays the same. Okay, it's going to stay at 64 until I hit that gas phase, and then I can start increasing the temperature again. The melting point, again, like I said, is equal to the freezing point. Okay, so melting and freezing happen in the same section. And the boiling point is the same as when condensation and vaporization happen. Okay, so B would be our melting / freezing point, and D would be our boiling / condensation point. So that's pretty much a heating graph. There's not really a lot to it. Sometimes we may be asked what our boiling point is, what our melting point is, and we're just looking at the temperature. Okay. We're just going to look over the temperature looking at a normal graph. Sometimes we ask how much heat is in that, and that's what we're going to look at next. And that has to do with calculating. Okay, so we're going to see this heating graph again, or heating curve again, but just know that these graphs can give you a lot of information if you know what you're looking for.